Alright, so this is the project running right here. We've got the water coming in through the top here. It's being pumped up from the bottom through this hose, through the flow meter, which measures the rate in. And then it's draining out the bottom here through this valve. The water level is going to drop at a steady rate here. And once it reaches this mark here, we're going to start our timer. This is our initial condition for our differential equation. So the water's about to reach this height, and go ahead and start the timer. Alright, so now the water is going to keep dropping, and the rate out here is based on the height of the water above the column, and the height is changing as the water comes out, but it's also changing as the water comes in. So based on this height function here, we're able to calculate the rate out minus the rate in. It's the differential. And we're able to take the time it takes to go from this point here with both valves fully open to reach an equilibrium point somewhere down here at a certain time. And our calculation is telling us that the water level is going to decrease steadily until it reaches equilibrium right at about this mark here, and that's going to take about 2 minutes and 10 seconds to reach here. And as you can see, this jug, it's got two sections here. This section is missing a handle part in the back. You can't really see it right now. But it's also got a section down here which is wider. So once the water reaches the end of this section, the flow rate slows down because of the larger cross-sectional area. And it slows down, it's got a larger cross-sectional area. That also means it takes more water to fill up the height, which those factors add up to a lower flow rate coming out. And it's going to reach this second section here in just a second. And what's the timer?
1 minute and 45 seconds.
So right now we're at 1 minute and 45 seconds. The rate is still going down. We've projected it to reach the equilibrium rate at around 2 minutes and 10 seconds at about this height right here. So once it reaches this height, it should be at equilibrium, theoretically. But there's a slight delay in the water coming in the top and going out the bottom. That's the time it takes for the water to reach the bottom of the tank from this height. So there's a slight delay in the time. That adds for marginal error in the level of equilibrium.
We're at 2 minutes and 25 seconds.
2 minutes and 25. Alright, so right now it's right at about this mark at about 2 minutes and 20 seconds, which is a little bit longer than what we calculated, but it's pretty close with the marginal error of the delay of the water coming in from the top to reach the bottom.